Chapter 8, Day 11 and 12, we are going to review all of the learning targets and information and content from Chapter 8 in preparation for the test. So you can check your answers here and see if you have any questions and reach out, potentially retaking a quiz. But today we're going to review all the learning targets from Chapter 8. And here's just a little application to kind of maybe tie this together. So it tells you that the area of a rectangle is x squared plus 13x plus 12. But what does that really mean? Well, we know that a rectangle has a length and a width. And to find the area of the rectangle, we have to take the length times the width. So what we know is that when we take the length times the width, it's equal to x squared plus 13x plus 12. So really what we're doing with this problem is we want to find the two factors, the length and the width, that get multiplied together to get that product. And so this is an example where we are trying to take this and factor it into the two binomials. So every time we factor, we always look for a GCF. There is not a GCF here because there's no number that goes into both 1, 13, and 12 except the number 1. And there is not an x in all three terms. So then what we can do is we can use the strategy for a quadratic trinomial where we look for two numbers that multiply to 12 and that add up to 13. So we start listing the factor pairs. Well, 2 times 6 is equal to 12. 3 times 4 is equal to 12. None of those add up to 13, however. But don't forget about 1 and 12. And that factor pair right there is the pair that multiplies together to 12 that adds up to 13. So those are the numbers that are going to go in the back of the parentheses. So we put in the 1 and the 12. They're both positive, so we know the signs are going to be plus, and then our variable goes in front. So the dimensions of our rectangle, the length is equal to x plus 12, and the width is equal to x plus 1, or vice versa. Okay, that's just a model. And so to find the perimeter, what we can do is we're going to add the sides together. Well, we know the other length is going to be x plus 12. And the other width is going to be x plus 1, so we're going to add these all together. So the perimeter of the rectangle is x plus 1 plus x plus 12 plus x plus 1 plus x plus 12. And when we add all of those together, remember, we're going to add like terms. So all of these x's get added together. We have 1x plus another x plus another x plus another x. So what we have is we have 4 x's. When we add up the plain old numbers together, we get 1 plus 12 plus 1 plus 12, and that would be 26. So that's the expression for our perimeter. So now it says if the area, or find the area if the value of x equals 2. Well, the simplest way to do this is to simply take our x value of 2 and put it in for x, and so that would give us 2 plus 1, or this width is equal to 3. 2 plus 1 is equal to 3, but I forgot to put the 1 in there. I added it in my head. So there we go. It's 2 plus 1. The other dimension is 2 plus 12, or that is equal to 14. So now when we find the area is equal to the length times the width. The length is 14 and the width is 3. So now we just go ahead and multiply 14 times 3, and that gives us 42. So our area is 42 units squared. So here is our area. Area is 42 units squared. This is also the expression for our area right here. So we can list it as the expression, or if we know the value of x, then we can actually go ahead and find the actual area. Otherwise, the area would just be an expression. The perimeter, now that I know the side lengths, I could simply just add all the sides, which would be 3 plus 14 plus 3 plus 14. So that would be 34 units. Or we could take that expression for perimeter and put in our value of x of 2, and that gives us 26 plus 8, which is also 34 units. And so now we have an actual number, which you're used to, but we also have, for the perimeter, we have an actual expression as well. So again, sometimes this math is out of context, but there are applications that we would be using this for. So let's just review factoring for a minute. The very first thing, whenever it asks you to factor, you need to remember that to factor, you are trying to find the two things that multiply together that equal what your product is. And the product is what you are starting with, whatever quadratic, trinomial, or whatever polynomial you start with. No matter what, though, whenever we are asked to factor, the very first thing we always have to do in every single problem is to find the GCF and factor that GCF out. Once we do that, then we see, can we continue to factor it? And if so, we could factor the remaining trinomial, if we can, by using multiply and add up if it is in the form of ax squared plus bx plus c, and this a value is a 1. Or we can use guess and check, the box method, or any other method right here when our a value is greater than 1. So when we have ax squared plus bx plus c, and those are the things we're going to work on. So here are some warm-up problems that we have been working on in the past. So I'd like you to pause the video, try these 4 questions, and see if you can get them correct. And then restart the video for explanation and answers. Again, the very first thing you do when you look to factor is to look for a GCF. The first one does have a GCF because there are x's in each one and z's in each one right here. The most x's in common is 1, so it's x, 1x, because this is to the first power, and the most z's in common is to the third power. So my GCF is xz to the third, so I know that's how it's going to start. Then I'm going to multiply that by another factor, and that's going to give me that product. So now, in order to get that inside factor, the second factor is I divide by my greatest common factor. And when I divide, I'll still be left with the 3. The x squared over the x cancels out to x to the first. I still have that y in there, and then z to the fourth over z to the third is going to give me just 1z, or z to the first. So now I just keep that same symbol in there, and now 8, there's no number to cancel with, but x over x, that reduces and cancels to 1. Not just goes away, it's not 0, but that reduces to 1. Anything divided by itself is 1, so 8 times 1 is 1. Z to the third divided by z to the third is 1. 8 times 1 is 1, and so that's why we're left with our final answer of just 8 for that last term. So there should be your answer to the first question. The second question does not have a GCF, and since the number in front of x squared is a 1, this is the kind that we can use the strategy where we multiply and add up. And so we look for two numbers that multiply to negative 14 that add up to negative 5. Well, 2 times 7 is 14, but that's not negative. So one of these numbers would have to be negative. And you can check both of those and see if any of them add up to 5. Well, this one right here adds up to negative 5. So I know those are the numbers that are going to go in the back of my parentheses, the 2 and the minus 7. What goes in the front of the parentheses is the x's. So this is going to be x plus 2 times x minus 7. And remember, all of this comes from the fact that when you multiply the first term times the first term, or x times x, it always gives you this first term. And when we multiply the last term right here times the last term right here, it always gives us the last term. How we get this negative 5x right here is from multiplying these outside terms, which would be negative 7x, and these inside terms, which would be 2x. And when I combine these together, that's what gives me that negative 5x. So that's the strategy. Question number 3 also has a GCF, and the GCF is 2. So the first thing I do is I factor out that GCF by dividing each of these terms by 2, and then what's left gives us x squared plus 8x minus 21. So looks like you might be done, except we always need to look at the inside right here to see can we factor this some more? And the answer is yes, because the number in front is a 1, and this is a quadratic trinomial, so we're going to try to find two numbers that multiply to negative 21 that add up to 4. So what multiplies to negative 21? Well, 7 times 3 is 21. So to get negative 21, one of those numbers would have to be negative. Do any of those add up to 4? And the answer is yes. These two numbers right here add up to negative 4. So what's going to go in my parentheses is those two numbers. So I'm going to have plus 7, and I'm going to have minus 3, and again the x's go in. So there's our answer to the second question here. So I'll box in this first answer since I didn't do that originally, and here is the next answer. The final answer is 2 times x plus 7 times x minus 3. Now, the last question does not have a GCF. And here's the kind that become kind of difficult, because what you have here is you have a number in front, you have an a value that is greater than 1. So what you need to do here is you either need to you have some strategies of guess and check, you have the box method, or you have the method that we started to learn, and we don't really have a name for it, but this method right here, we multiply these a and c together, which would give us 12, and then we find the factors. Again, it's the same kind of thing. We're still looking for two numbers that multiply to 12 and that add to negative 8. So we start listing those pairs. Well, 3 times 4 multiply to 12. Or negative 3 times negative 4, but that adds up to 7. So let's try 6 and 2. Well, that adds up to positive 8. So what if we had negative 6 and negative 2? Well, that's the combination we need right here. That is going to multiply to positive 12, but add up to negative 8. Okay, so now we found those two numbers. So here's where it gets kind of tricky again. So what we need to do is we need to draw those two parentheses, and just like we do in the other strategies, we fill in those numbers. So negative 6 and negative 2. What goes in the front is not just like your variable. This is the difference. It's not just your variable, it's your whole like 3n. But it's going to go in both places. So when we did guess and check, we just put 3n and n because we know the first term times the first term has to equal the first term. And that's not the case here. So how we take care of that process is we divide by a GCF, which in this case would be 3. There is no GCF there, so we would just divide by 1 or not divide. So what happens with our final answer here is we get 3 divided by 3, which is 1, or 1n minus 2 times 3n minus 2. And that becomes our final answer for this problem. Now, we started working on that process, okay? But we could have easily done the same thing here with what the strategy that I showed you earlier on, which was guess and check. So I'm going to go back and just show you that as well. So I'm going to rewrite this 3n squared minus 8n plus 4. And how we did this process is we still know the same thing, that the first term right here times the first term right here always has to equal the first term. So what's going to give you 3n squared? If we didn't have a 3, it would be n and n. That would give us n squared. So one of these is going to have to be 3n. So that's going to give us, that's going to work out. The problem here is that we still want to look for two numbers that multiply to this last term. But the problem is they're not going to add up to that middle term. We won't be able to see if they're adding up to that middle term until we try it. So I'm going to start listing factors of 4. Well, 1 and 4 or 2 and 2. Now, you might have these also be -1 and -4 or -2 and -2. Those would also give you a positive 4. So those are your combinations to try. So I'm just going to go ahead and start with this combination right here. I'm going to try putting in +1 and +4. So again, this last term times the last term is giving me 4. So now I need to check to see if I'm getting this -8n right here. So 3n times 4 is 12n. 1 times n is 1n. And when I combine these together, right here, that is not giving me -8. And even if both of those numbers were negative, that would give me -13 instead of +13. So that's still not going to work. So I've just discovered that that combination doesn't work. So the next thing I actually try is I try putting the 4 over here and the 1 right there. And this can get kind of messy, but I'm going to go ahead and try it this way one more time before I rewrite it. You could rewrite it every time. So now I'm going to try multiplying 3n times 1, which is 3n, and 4 times n, which is 4n. But again, that only adds up to 7n, so that combination also is not going to work. So now I'm going to rewrite this. Again, this guess and check is not always the simplest, okay, but it shows you a lot of the relationships. So I'm still going to keep that 3n times the 3n because that is always going to give me that first term 3n squared. So I already tried this combination and that didn't work. So now I'm going to try the 2 and the 2. So now I'm going to try putting in +2 and +2. So I'm going to try this combination right here. So now let's see what's happened, because again, the last term here times the last term here is giving me that last term right here of 4. Now I need to check to see if I'm getting that -8 again. So 3n times 2 is 6n. 2 times n is 2n. And when I add these together, I get 8n. Well, that's awfully close, but I need -8n. So all I need to do is I need to change the sign so that this is a negative and this is a negative. And now that gives me 3 times -2 gives me -6 and -2, which does add to that -8. So now I know I have the right combination of numbers, and so I'm going to rewrite the entire problem. 3n minus 2 times n minus 2, and that is my answer to this question. And as you can see, we already did it with the newer method, and you can see these are the same. The order is different, but the two factors that we have right here are the same in both problems. This factor and this factor matches up with this factor and this factor. And there are other methods as well. We've worked on the box method, and I actually posted a video for the snowflake or asterisk method as well. And what you need to do is kind of figure out which of these methods makes the most sense to you, and then continue using that method moving forward. Okay, so we have a few more questions to try. What I would like you to do, or let's actually try one of these together, and then I will work out some of the other solutions and post them for you with video explanations as well. So let's try number 6 together. Pause the video and see if you can try to factor number 6. Number 6 does have a GCF. The GCF for number 6 is 2. 2 goes into all of those numbers. So I'm going to divide each of these by 2. So that is going to give me 2 times 3x squared plus 4x minus 15. Okay, so Now I can see that I have this quadratic trinomial, but I also can see that this a value right here is not 1. So I can't just use the simple multiply and add up strategy. So either use guess and check to do this inside part, or we can try this new method where we multiply a times c, which is going to give us negative 45. We are looking for the two numbers that multiply to negative 45 and that add to 4. So let's work on, we know 9 and 5, but one would have to be negative. Neither of those add up to positive 4. Oh, wait. These do add up to positive 4. This one right here. So now that I find those factors, and I'm just going to kind of lightly right now kind of draw through that. So now that I found those factors, I go back and I put those numbers in my parentheses. The difference on this method is I have to put in this whole piece 3x for both, which is kind of weird, I know, but that's what we need to do. We also have to remember that we need this 2 that we factored out already as well. So now we're almost done, but we do need to see if there is a GCF that we need to divide by. Is there a number that goes into both 3 and 9? The answer is yes, 3. There's not a number that goes into both of these, so we just divide by 1 or don't divide. So now what we have is 2, that greatest common factor we took out. And when we divide by 3, we get x plus 3. Because we have to divide both of these by the 3. And then when we get in the second parenthesis is 3x minus 5. Now this process does make things a little bit simpler, but you have to remember some things about it, like what numbers you have to multiply, which ones you have to put in that front of the parenthesis, etc. Okay, so the other strategy, again, that I've been trying to share with you is that sort of guess and check process. All right, let's do one more here from this list. Let's do number 7. So pause the video, see how far you can get on number 7 on your own. Okay, we always look for a GCF. Well, there is not a number that goes into all 3 of these numbers, because 3 is prime, so is 23. There's x's in 2 of the terms, but not the third. There's y's in 2 of the terms, but not all 3. So there is no GCF. It's not a quadratic trinomial, okay? So this one, in fact, is relatively prime. Or it can't be factored. Didn't mean to do a tricky one with you, but again, just trying to practice some together. And from this one here, let's see if we can try number 10. So again, pause the video, try number 10, and then restart the video to see if you got it correct. Number 10 does have a GCF because there is a number that goes into all 3 of these, and that is 3. So now when I divide by the GCF, that's going to give me what goes in the parenthesis. My GCF is one factor, and then the other factor, when I take 6p and divide it by 3, I get 2p. When I take 15p squared divided by 3, I get 5p squared. And when I take negative 9 divided by 3, I get negative 3pq. And again, this is not a quadratic trinomial. We don't have like an x squared, an x to the first, and then a constant. So this would be our final answer. It can't be factored any further than that. All right, one more. Let's try this last one. Let's do number 3. So pause the video, give it a try, and then restart the video to see if you got it correct. Okay, this kind, we don't have a greatest common factor. There is a 1 in front, so this is the kind that we can look for 2 numbers that multiply to negative 28 that add up to negative 12. So I'm going to start listing the factors of negative 28. Well, I think of 7 times 4, but 1 would have to be negative. None of those add up to negative 12. So what else goes into 28? Well, 2 goes in there. So 2 and 14, but one of those would have to be negative. And now I can see that this is the combination that would add up to negative 12. So those are the numbers I'm going to put in. So my factored form, my 2 is going to go in there. Remember, it's positive, there's no sign with it, and negative 14, and then I fill it in with whatever variable I have in my problem. And then this is my factored answer. So that gives you some extra practice on some of these. That's what I'm going to, stop with in the video here. But I will probably work out some additional ones in the notes for you to try some of these on your own and then check your answers. But this is the end of the video.